Hi everyone, it's Mr. H here, and today we're going to talk about the properties of parallel lines. Now we know that when we graph a line, we graph it using the formula y equals mx plus b. And so the slope is the m value and the y-intercept is the b value. You'll notice that each of these has the same slope. And in fact, the slope, if it's a whole number, it's like it's over 1. And in this case, we have a y-intercept of 1, and we have a y-intercept of negative 3. And so if I graph these two lines, here's what they're going to look like. The first one's going to have a y-intercept of 1, then it's going to rise 3 over 1, like so. And then the other one is going to have a y-intercept of negative 3, and it's going to rise 3 over 1, rise 3 over 1, rise 3 over 1. And so I'm going to continue that pattern, and I'm going to draw a line between those points. So as you can see, the first one is y equals 3x plus 1. And the next one is y equals 3x minus 3. Now, hopefully you notice that because they have the same slope and they don't have the same y-intercept, that these two lines are forever going to be the same distance apart. We can go up and up forever, or we can go down and down over here forever. They're always going to be the same distance apart. And that's a property of parallel lines. If we have parallel lines, that means that they will never cross. Parallel lines never cross. Another thing we know about parallel lines is that if they have the same slope and they have different y-intercepts, then they are parallel lines, as we can see in this particular example. But that applies to anything. Let's do one other example of a couple of lines and see how this works. So now I have two more equations that are down in the bottom left corner. And you can see what those two equations are, and you can see they have the same slope. And in this first case, the y-intercept is 4, and in this case, the y-intercept is negative 2. So I'm going to go ahead and graph these. And you can practice these, pause the video, and practice yourself, just to make sure that you're good graphing these as well. I know we've done this in our previous unit, but it's always good to review this. So I have a y-intercept of 4, and then it's negative 2 and 3. So rise is negative 2, run is 3. Rise is negative 2, run is 3. And so these lines, or this first one, is going to have those points. And the next line starts at negative 2 and then goes down 2 over 3, down 2 over 3, down 2 over 3. And so if I label these two lines, again, you can see that these two lines, because they have the same slope, are also going to be parallel and never cross. And so that's the property. Anytime we have the same slope, we have parallel lines. Even if they have very different y-intercepts, they're never going to cross, they're going to be parallel lines. I want to do one final example where it might not be in the form y equals mx plus b. It's actually going to be in standard form. So let's look at that together now. So this question says, write the equations of two lines that are parallel to 2x minus 8y minus 10 equals 0. You might recognize this as standard form, and hopefully you do recognize this as standard form. Remember that standard form is a times x plus b times y plus c equals 0, where a, b, and c are some numbers, positive or negative. So what we're trying to do is we're trying to take this from this form, and we're trying to write it in the form y equals mx plus b. So let's go ahead and first isolate this 8y, or this minus 8y. Now if I want to make it by itself, the easiest way to do that is add 8y to both sides. So I'm just going to write out that same line again and then show you how I'm going to add 8y to both sides. If I add 8y to this side, it's going to cancel out. If I add 8y to this side, I get 8y equals 2x minus 10. At this point, we can divide both sides by the coefficient. So we divide this by 8. And this gives me 1 over 4, because 2 over 8 simplifies to 1 over 4. 1 over 4x minus, and 10 over 8 simplifies to 5 over 4, or 1.25. So writing it with the y first, I can write it as y equals 1/4 x minus 5 over 4. So if I was to graph that line, 5 over 4 is 1.25, or negative 1.25 here because it's a minus. And then you would say the rise is 1, the run is 4, and we're going to have it's positive, so rise 1, run 4. So we're going here, rise 1, run 4, etc. And then we could, if you wanted to put another point on here, you could even go and use the pattern backwards. Go across 4 to the left and then 1 down like that. And so what we're going to get is a line that looks like the following. So there it is right there. And the equation for that line, we would use the original form that equation is this. So how do we find two lines that are parallel? Well, you could literally find an infinite number of lines that are parallel, because you can list any single line that has the same slope. Let me give you an example. I could have a y-intercept of 4. Rise 1, run 4, rise 1, run 4. And then I could draw a line through those. I also could have, let's say, -8. And if I was down there, I rise 1, run 4, rise 1, run 4. And then I could draw a line through those. So let's do that and see what that looks like. So this line, we can see, is 1/4 x plus 4. This line down here is 1/4 x minus 8. And so all we have to do is change the y-intercept. So we don't even have to graph this to answer the question. We can just get it into this form, look at the slope, and then we could literally start listing things. We could say y equals 1/4 x plus 1, y equals 1/4 x plus 2. We could say y equals 1/4 x plus 0, which is just 1/4 x. The key is all it has to have is the same slope. So once you have it in the form y equals mx plus b, you write a new equation with the same slope and you change the y-intercept. You write an equation with the same slope and change the y-intercept. So you can go ahead and pause the video before it stops in a few seconds and write that down. Write an equation with the same slope and change the y-intercept.